Hmm. Hi everyone, I am Sanat Popli and I am a teaching assistant for Info 7390, that is Advances Data Sciences and Architecture under Professor Nick Brown, and this is my first video, that is correlation versus causality. Like today we are talking one of the most common mistake people make with data, that is confusing correlation with causation. This is important as data scientists. We are not just predicting outcomes, we want to understand why things happen. So let's talk about the big idea. So let's start with the correlation. Correlation measures how two variables move together. Like if you have seen this thing, y is equals to ax plus c. So basically, this is how two variables move together. If there is a change in x, then there will be a change in y value. Like this is a very simple linear regression variable, which we also call um, correlation. Let's take a real life example in that. That is ice cream. Ice cream sales and drowning incidents are highly correlated. But does eating ice creams cause drowning? Of course not. The hidden factor is hot weather. So while correlation tell us what moves together, causation tell us what drives what. Let's talk about the correlation formula. So this is a correlation formula, that is correlation of x and y is covariation in xy upon standard deviation of x dot standard deviation of y. This is a very standard formula that we use in numericals as well as in real life, that how to uh, basically get the correlation of x and y. Why this matter? Why do we care? Because mistaking correlation for causation can lead to really bad decisions. Example of common mistakes we can take, that is first in business. A company might think higher ad spend causes more sales, when actually both are driven by seasonal demands. Let's talk about the second example, that is healthcare. A treatment may look effective simply because healthier patient chooses it. And third is a general life example. Like in real life, we are surrounded by correlation, but data science must go further. It has to identify causal relationships. Let's talk about how to think causally. So, how do we move from correlation to causation? We ask a causal question. What would have happened if things were different? This is called the counterfactual approach. Like example, did a student's test score improve because of tutoring, or would they have done just as well without it? This what if mindset is the foundation of causal interface. Like if we talk about counterfactual framework, like for the same individual, that is y1 is equals to outcome with treatment, that is example tutoring, and y0 is outcome without treatment. So causal effect is y1 minus y0. Like if we talk about the difference between correlation and causation. I'm sorry for the terrible handwriting, but yeah, we have to like manage it. So, if we talk about correlation, so basically correlation of x and y is equals to covariance of x comma y upon standard deviation of x into standard deviation of y. But what is causation? Causation is basically the two variables do not depend upon each other. That's what data science teaches us. Always that correlation is not the only concept. So, what is causation? Causation of x and y is equals to, or we can basically just put x and y over here, and I'm putting 1 and 0 like we have seen. Like 1 is basically effect with tutoring, and that zero is no tutoring. So that's how causation works. Basically, the difference of two things. So the problem is we can never observe both y1 and y0 for the same person at same time. So let's take the part 4, that is quick real world case. Tech companies use this thinking all the time in A/B test. They don't just ask, do users who see the feature click more? They ask, if we intervene and show this feature, does it cause click to increase compared to not showing it? This causation in action. A/B test example we can take like group A, that is treatment. Users see new features. Group B, that is control. Users see old version. Causal question, does the new feature cause increased engagement? So to wrap up with, we can say correlation shows association, not cause and effect. Causality asks the deeper counterfactual question, what if things were different? For the next interview episode preview, we will dive deeper into the counterfactual framework and introduce the potential outcome model, which is the backbone of modern causal interface. Thank you for watching and see you in episode 2. Bye bye.